Hello and welcome to the lab, Electrostatic Charging. What you see here is the equipment that's needed for this experiment. We have right here 3 charge producers / proof planes. These are going to be what we're going to use to charge this, which is a Faraday ice pail. We also have a charge detector. It's a sensor right here, which has a connector for our box for data acquisition, the actual device itself, and also a pair of alligator clips that's used to go across the pail here in order to detect charge difference. In the next video, I'm going to show you the experiment as set up, and then we'll do a trial run. This is the experiment as set up. As you can see, the charge detector has been connected to the Faraday ice pail with the large alligator clamp, which denotes positive, connected to the inside part, and the negative part connected to the outside part. You can also see here we have 3 different charge producers / proof planes. We have a blue one, which is what this one is right here. It looks black, but it's actually very dark blue. We have a metallic one right here, and then we have a white one. Now, in the lab itself, it says for you to rub the proof planes together in order to do the experiment. So, for example, here, what you would do would be to take this one right here, you'd put it in contact with this and rub it back and forth like this. And what that does is to rub the charge off of one of these onto the other, making it have a net charge that's not 0. Now then, what you would do would be to place your proof plane here into the center of the pail without being while making sure not to touch the edges. If you touch the edges, then what happens is the charge flows from this into the metal mesh right here. So the idea here is that you're looking at the charge of this by allowing it to induce a charge on your metal ice pail here. And that's actually what you're measuring. So for example, if this were negatively charged, I would place it in here, and then what happens is the positive charges that make up the metal stay in place, but the negatives here would move to the outside of the center pail, and as a consequence what they do is to cause the negatives here to move to the outside, and you can actually measure the difference, what we call the potential difference here, which allows us to calculate the charge, or at least it's done in software. So there are a number of different variations in which we do this as laid out in the lab, and I'll be talking about those in the video that I do that explains the theory.
Hi, and welcome to the theory section for Lab 5. Lab 5 deals with electrostatic charging, which is charging by inductance. So basically what you're doing when you rub your proof planes together is to take electrons off of one thing and put them onto something else. So let's pretend that you have a proof plane, which I'll draw like this. So here's my proof plane, and we're going to pretend that this thing is positively charged. So if it's positively charged, what that means is that I've rubbed the electrons off of it onto something else. So what I'm going to do is to take this proof plane and put it into the ice pail like this, okay? Making care not to touch any of the edges because we don't want direct charge transference. So as this thing goes in like this, what happens is the following. So let's again pretend that this is positive. Well, any negatives that are in the metal, and the negatives are in the electrons, and this is these are metal pails, and if you remember, in previous lectures and what have you, the electrons are the things that are really mobile. So any free electrons that are in here are going to be attracted to the positive. So what's going to happen is this inner pail, at least this side of it, will develop an overly negative charge. Now, if this wire were not connected through the detector to this other side of the pail, what would happen would be, for every negative charge that you had pulled towards the positive, you would have an accompanying positive charge on the outside, making this inner pail have a net charge of 0. But what these wires do is they allow the electrons that are on this to be conducted away onto this. So they're a connection. Okay? So the act of putting this in here allows the electrons here to move through and to be deposited on here, thereby charging the inner pail. So when you put this in here, what you're doing is you're pulling electrons from here onto this. So if I were to use a different one, this case, we'll say we have a negative one. So what I've done is I've put electrons onto this. When I take and I put this in here, then what that does is to push the electrons that are free away. Now they have an exit path. Again, the inner pail is connected to the outer pail through the detector, and that acts like a ferry, a way to conduct. So in that case, what happens is the negatives leave like this. They get deposited onto this outer pail, and what that does is to leave a bulk positive charge on the inside like this. Okay? So that's generally what happens whenever you take and you charge things by inductance like this. Inductance means to induce. You're not directly putting the charge onto it. What you're doing is you're inducing the charge to be there by allowing a path out like this, or in. So that's the theory section for this lab, and I will see you in the next lab.